Hello, everyone. Thanks for joining me today at Chi Security Conference. I'll be talking on secure coding based practices on a Blue Team stage. Let me briefly introduce about myself. I'm Viraj Gandhi. I'm Senior Staff Product Security Engineer at the SailPoint. As a product security leader, I have successfully led ship-to-left transformation of security programs solving the open source security and application security domain at various organizations. So let's just get started. I would like to start with talking about the modern software development. As the technology has evolved, we have seen modern software development has evolved too. It has lots of moving parts like agile methodology, the DevOps, the Kubernetes deployment, and all of those have accelerated the software development, but at the same time has added the complexity and also have made the software development insecure. There is always a rush in releasing the software in the market, and security is always considered as the second priority. And we have seen that the threat landscape has changes as the technology has evolved, and there is a sudden rise of the ransomware attack, the data breaches, which is bringing the company's brand down. A tiny bit of code mistake, it can impact the company. Company can face a millions of loss in the revenue. It can be a big Wall Street Journal news as well as losing the customer. For that reason, never ever before, but now there is a need to start following the secure coding best practices. If you see, the monthly release of the software development has now increased of developer pushing 10 times in a day the code to the production. And if you think there are million lines of the code getting produced across the globe in day to day, but how many security engineers we have in testing those software, those code, even the company can't afford the security tooling enable so that they can detect those vulnerabilities as early as possible. For that reason, there is a need to have this secure coding based practices. As a product security engineer, we are just trying to provide a secure paved path for our developers, making sure that they can consider the automation as their arsenal and start embed that security in the development lifecycle by enabling the various tools like the SAAS, DAS, KIAS, which will be acting as the guardrails in the development lifecycle. And that's how you can secure your pipeline. That's how you can start having the secure development life cycles. In this diagram, you see you can have the software composition analysis, the static analyzer that scans the source code as early as possible so that you can detect those vulnerability and try to fix at the design early phase rather than doing a much later stage. And also it is very cost effective if you start fixing those vulnerability as early as possible. Now let's get started with the basic security concept that every engineer, analyst, QA should know who is involved in the software development is the CIA triad, which is the confidentiality, integrity, and availability. The confidentiality is like, only the authorized user have access to the data. Integrity is only the authorized user able to update, make changes to the data. And the availability is that whenever the authorized user is trying to access the data, it should be available. There might be the question arising in your mind is that, which language is considered to be more secure compared to the another. Maybe I'll just use a more secure language in my software development. Well, there is no such secure language. You decide the language based on your feature need, based on your business logic. Every language is going to inherit the vulnerabilities one or another, but you start understanding what are the secure frameworks you can leverage, what are the secure coding principles for that language you need to follow whenever you are writing code using that language. These are the key things to be considered in the mind. So I hope everyone is familiar with the OWASP, which is Open Web Application Security Project. They have provided the top 10 secure coding principles. I'll be covering a few of them because of the time constraint. So let's get started. The first one is about minimizing the attack surface. Here you see there are the two buildings, the left and the right. Can anyone point me which is more secure compared to the another one? Well, if you see the right side building has a less doors and the window, so the attack surface is very less. There are less protection controls you need to consider, you need to keep. Whereas on the left side, because there are more doors and the windows, you have to provide more security protection around that building. It's same way with your software. Try to reduce your attack surface. If there are any unwanted code, unwanted libraries which has been depreciated, not heavily being maintained or used in your software, try to leverage of running the attack surface analysis tool and try to detect and remove that unwanted code from your software. If there are any ports open which are not needed, try to disable the do code. The ports, do the proper security hardening, making sure there are no ports interfaces exposed which are not needed to be the part of your software. That's how you can reduce your attack surface and reducing the chance for attacker to exploit. The second one is my personal favorite, which is never trust the user input. So let's say if there is a text box in a form where you are expecting user to enter something, or even you are expecting user to upload the image in an image folder, if there is no proper validation or sanitization check done, it can bring the server down. It can result into the big security loophole. For that reason, always make sure that you are doing proper validation. There are two types of the validation you can do. One is the client side, where you are providing a quick feedback. So let's say in your text box, if you are expecting user to enter just the phone number, if someone has entered some A to Z characters, you can quickly through the highlighting in the red color box, you can highlight that only the numbers are accepted, not the characters. That provides a rich user experience, but it can be easily bypassed by tweaking those JavaScript from the browser inspect element. For that reason, always make sure you also have the server-side validation, which is the code is not visible to the end user, they cannot tweak it, and combination of the client side plus the server side will provide more efficient, secure way of doing those input validation check, and that way you can try to minimize any sort of injection attack. The one key thing to keep in the mind is always go with the allow list versus the deny list approach. So one good example is, let's say if you're throwing the party in the house, you will be obviously maintaining the list of the user who are allowed to enter in your house, not the list of the person across the globe who are not allowed in your house, right? It's very hard to maintain that deny list. At the same way, let's say in the text box, if the expectation for user is to just enter the number, make sure you define your regex in such a way that it allows only the number, rather going with the denial list of approach of just coming up with the regex where what characters are allowed, what are not allowed, because you might be overlooking some characters, you might be missing them out. So always follow allow versus the denial list approach. The next one is the POLP, which is also known as the principle of the list privilege. It tells that at any given point, user should have access to the data and application which is needed to perform his role, perform his duty on day-to-day basis. No user should be having some high privilege role which is not needed to perform his job role. Same way, keep this ring structure in the mind the next time whenever you are writing the code. If the end user doesn't need to have a sudo access, doesn't need to do any server config changes, keep him in the ring 3 or a ring 2. Whereas if an admin who need to make some config changes, he has to be part of the ring 0 or the ring 1. So always make sure you follow this principle of the list privilege. Identity access management, the IAM, follow this principle, and following this principle, it will not completely prevent from any sort of injection attack, but it will make difficult for an attacker to exploit the injection attack further. For that reason, we need to follow the principle of the least privilege. The next one is the defense in a depth. You need to consider the software as the fortress of your assets. So you might have seen the kingdom in the older days. They were always built on the top of the hill, surrounded by the lake, pond, having a tall outer walls with the towers and inner thicker walls, and the army surrounded on the outer perimeter, so that it helps in detecting if there is any enemy approaching to that kingdom. In the same way, in your software, where one control is reasonable, try to come up with the multiple defense layer, multiple layer of the protection. So there is no single point of the failure. If the one control fails, at least there are sufficient other layers of protection to keep your software secure. And always the different multiple layers of the control will gonna react to a different attack in a different way. For that reason, we need to follow this defense in a depth. I highly recommend to refer to this diagram the next time when you are building any features from the scratch or writing a very large size project. The diagram suggests that, what kind of the protection you can think to apply at the application level, at the network layer, at the database layer. And like said, having those multiple layers of the controls at the multiple layer will make your software more secure. And also keep in mind that, you can't just let's enable all the controls stated in this diagram. It can be more expensive. So it based on the criticality and the widely consumption of the software, you need to come up with a list of the multiple layer of the control which are making sense and needed for your software to protect from an attacker. The next one is the establish secure default. So out of box, any software getting released should always be coming with a maximum security. It should follow all the previous principle what I went over, like the principle of least privilege, defense in depth. Let's say your feature is about the authentication, make sure it has the strong password policy defined along with the rate limiting, the retry policy, and leave it up to the end user, the customer, if they want to relax certain policy. But by default, the software should be released with the maximum security. So it should be secure by the default. The separation of the duty, it's a key thing and much needed for regulators. And also that's what the GDPR and the SOX audit team look for it. So every organization have to make sure they are following the separation of the duty, which tell that, no user have more than needed control over the processes in order to avoid the conflict of interest and also the human error. The separation of duty is highly recommended to be practiced. So in this example, if you see, if the administrator is managing the employee data, the roles duties of the employee data, he should not be having visibility about the compensation of the user of the employee data. Only the HR should be responsible and having the visibility of the compensation of the data. That way you can avoid the conflict of the interest. The another good example is, let's say the manufacturer has issued some purchase order receipt. The analyst should be approving this receipt. The receipt should not be like, issued and purchased and approved by a same user. And again, like, to keep your auditor happy next time, make sure you are having this separation of the duties followed at the organization and as well as at the software level. Now, I would like to talk about the third-party libraries. We have recently seen there are many publicly disclosed vulnerabilities around the third-party libraries. Well, the third-party libraries have been heavily used by the software companies. There are a couple of the reasons, because they don't want to waste 6 to 9 months in waiting to develop the product from the scratch. They can quickly enable the feature by leveraging those library and quickly release to the market. It saves the time cost of leveraging the third-party libraries, but at the same time, it does add risk to your software There are a couple of the reasons for that. First of all, it's a primary attack vector for an attacker. You make sure that the third party library, what you are leveraging, are heavily maintained. You are updating those third party libraries, making sure you are patching them, upgrading them on regular basis. There shouldn't be any severe critical vulnerability sitting in those libraries. Whenever you try to leverage those libraries, look the number of the commits, how often the commits are there, number of the downloads for that library. That will tell you how heavily it's been maintained and widely used in the community. Make sure you have the software composition analysis scan running, or you can also leverage the OWASP dependency checker that will help in detecting those libraries. And you can quickly remediate by upgrading to the latest recommended version patch. Encapsulate the libraries, expose only the feature which is needed for your software to consume to leverage, and also maintain the repository of those third-party libraries where you have this SCA scan running continuously, where like the legal security engineer has provided an approval of consuming those library. Never download those library at the runtime directly from the internet. These are the few hygiene you need to consider when you are dealing with the third-party libraries into your software. The next one, very buzzing word, is about the software bill of the materials. This term is very known into manufacturing items. The software bill of the materials, it helps you to use the open source software in more secure and compliant way. It lists the ingredients, the software components which are being used to build that software more complex way. Sometimes it becomes very difficult in identifying, detecting any vulnerability if it is sitting in that complex software, because these days the software has become so complex. It involves so many third-party libraries, the open source components, and even like, through and lots of M&A, the companies inheriting the code from the other companies. And at that time, it becomes very difficult to manually detect if there is any vulnerability in one of the components. The software bill of the material will provide that, where this components is being used, and you can quickly remediate the vulnerability from that component. For that purpose, the software bill of the materials is highly recommended. The last year, the Biden government issued an executive order that any vendor selling the software to a federal agency have to provide a minimal software bill of the materials. And there are the couple of the benefits of using the software bill of the materials. It provides you the transparency, the supply chain risk is been reduced. It provides the resiliency in the supply chain, and also making sure that always the licensed product is getting used. And even if any software component, any software is going to end of the life, the vendor will stop providing the patch. At that time, the bill of the materials help in detecting those software. So it is benefit to the supplier, the purchaser, as well as to the software developers. Now, there might be question arising that if the bill of the material is providing the transparency, attacker can easily take the advantage of using that bill of materials and trying to exploit, where the concern is outweigh as the attacker, they have like efficient tools to exploit the vulnerability. They don't rely on the software bill of the materials. And also software bill of the materials, the executive order clearly states that it is not mandated to make it public. You can keep as a private, it's up to your choice. And it never reveals any intellectual property, a patent or algorithm. It is just list of the ingredients of software components which is being used to build that software. So there is a difference if you see in the ingredients and the recipe of the food. So same way, that's what the software bill of the material is. I'd like to give a few tips to be keep in mind the next time when you are doing the coding is engage security engineers, start doing the threat modeling at the design phase for any new feature you are building. That help you to detect the threats vulnerability as early as possible. Never trust the user input. Always go with the allow versus denialist approach. Make sure the automation is your arsenal, but don't rely completely. There might be a complex business logic which needs the manual intervention, and keep your software more secure, simple, rather making it complex. And just to conclude, try to embed the security in your development lifecycle. It is just a matter of practice. It might be overwhelming when you start following the secure coding principle, but keeping those secure coding principle and having that security mindset will will take you pride of, like, producing the software quickly. And also for QA engineer, the next time, like, when you are considering the functional regression or the performance testing, consider security as one of the control for the testing. That's how, like, you can have a secure development life cycle. These are the few links you can follow if you are interested in reviewing what are the API security checklists, what are the secure coding review checklist. OWASP website has a good in-depth with example details on the secure coding principles. And thank you so much for listening to me. And I hope you guys had a wonderful information to take away from this talk. Feel free to connect me on the LinkedIn for any career advice or any AppSec related question you have. And don't forget to provide the feedback of my talk. And also please take a note of this link. Feel free to download the materials. In the materials, I have provided the secure code review checklist and the API security checklist. It will be benefited to any architect, to any security engineer or QA engineer whenever you are doing the code review, developing the code or testing the code. And thank you so much. Now I'm opening the floor for any Q&A.